Okay, let's talk about methods or the statistics that health economists use to study the things that they study and to inform the policies that they influence. An overview of what we're going to cover today will be linear regression, which is an extremely popular tool used to measure the relationships between variables. It's definitely widely used in economics, and it also has plenty of applications in other disciplines. And we are going to go over predictions and marginal effects, what those mean in the context of linear regression. We're going to talk about statistical significance, which is how we know whether our variables and our model makes much difference in what we're trying to study. We're going to look at R squared, which tells us if our model is any good, and multivariate regression, which is a fairly straightforward extension of linear regression. It just involves more variables and more numbers, which is great. And we'll get into elasticity, which is a concept that we've covered before with respect to demand for healthcare. And we'll talk about the role of natural logs and how to interpret those in regression. And of course, regression is all well and good, but study design is really important in order to establish claims about causality. And so we'll go over the difference in differences model, which is one of the most commonly used one of the most commonly used approaches in modern empirical economics, even though it has its strengths and weaknesses. So fundamentally, this is about relationships in data. That is what economists tend to spend a lot of their time looking at. So let's take a look at this graph. On the right here, we've got a scatter plot of individuals. These are adults. The data comes from MEPS, the Medical Expenditure Panel Survey that's created by AHRQ, or the Agency for Healthcare Research and Quality. So take a look at this and just think for a moment, in your own words, how would you describe the relationship between height and weight? A pretty reasonable answer to this might be something like, well, it looks to be kind of a vaguely positive relationship, but it's not that strong. Generally speaking, it looks like the taller you are, the more you weigh, but there are plenty of exceptions to that rule. And that is a perfectly serviceable way to describe this relationship, but economists usually prefer to be a little bit more precise. Really what linear regression is about is just putting some more clarity around this relationship. So we're estimating, in particular, a linear relationship between these two variables, y and x. You've got the outcome variable or the dependent variable or the left-hand side variable. You can take your pick of any of those three. We call that y. This is, and then x is our independent variable, or sometimes in medical literatures they'll say exposure variable. But really what we're doing is just we're coming up with a y equals mx plus b kind of an equation. So we we estimate y through an intercept plus some slope times our x variable. So in this example, weight is related to height, weight in pounds, height in inches. We could just eyeball it and see that taller people weigh more on average, but we can get a lot more precise than that. And we can do a lot more with more precise stuff. So using regression, you can test whether taller people weigh more. It's one thing to kind of make that vague observation, but it's quite another to put the statistics around it and make a strong claim about that. We can test whether the relationship is linear or quadratic, which is very helpful because we might expect, for good reason perhaps, that the relationship between height and weight is not the same at every level of height. So maybe for those who are shorter, a 1-inch change creates some modest change in weight, but for those who are already very tall, a 1-inch increase in height could lead to a fairly substantial weight gain just due to body proportions. We can test whether the relationship between height and weight is the same for men and women, and we can see if age matters. Maybe those who are in their 20s have a different relationship between height and weight, and those who are over the age of 75 have some other kind of a relationship. So all of these things you can do with linear regression. So we're using MEPS data, which I alluded to just a moment ago. It's from 2000. We're looking at non-elderly adults, so between the ages of 21 through 65 in this particular context. We've got a little bit over 13,000 observations in the data set, which is pretty nice for a pretty nice survey size. And we've got it cleaned up just a little bit so that we don't have missing values or funky values that look like outliers that don't really belong. And here's what the summary statistics look like. So out of those 13,000, we're looking at a mean age of 41 years, mean weight of 174 pounds, mean height of 5'7", and just under half the sample are recorded as men in this data set. So the average person in this data set is just over 40, weighs about 175 pounds, roughly 5'7", and there's a 50-50 chance that they're listed as a male in this data set. Let's just take a look at a scatter plot of 500 observations. That's a little bit easier visually, I think, than plotting all 13,000. So here we've added lines for BMI categories. So this is again a scatter plot. Height out here on the x-axis, height's our x variable. Weight up here on the y-axis, that's our y variable. The green line on the lower end here is an underweight line. So those below this line are listed as underweight as classified by BMI, and I'm sorry, for body mass index. And this upper line here represents anyone who's north of this line would be listed as obese as calculated by BMI. And so this corresponds to some of our general intuitions about what we know about the US population, which is the population from which this sample is drawn. We know that somewhere between about 30 to 40% of adults are listed as obese in the United States, and that seems to be pretty correct with this data. So we've got a good chunk of them that are above the obesity line, a few that are underweight, and most of them that are here in the middle, somewhere between them.